आज के वीडियो में हम लोग 3 इंपॉर्टेंट आइडेंटिटीज के बारे में पढ़ने वाले हैं और कुछ इंपॉर्टेंट क्वेश्चन सॉल्व करेंगे, जिससे हमारा जो डिस्क्रीट स्ट्रक्चर्स के क्वेश्चन है, जो प्रूव करने वाले क्वेश्चंस आते हैं, वी कैन डील विद देम इजीली. सो फर्स्ट ऑफ ऑल लेट मी इंट्रोड्यूस यू सम 3 आइडेंटिटीज. राइट, फर्स्ट इज P implies Q is equivalent to negation of P or Q. Second is biconditional theorem. Right, biconditional theorem is P if and only if Q is equivalent to P implies Q and Q implies P. And third one is negation of P implies Q is equivalent to P and negation of Q. Right. So what does it actually mean? One by one we will discuss. First, here it means P implies Q. That means if P happens, Q will happen. This is a bound promise, right? But this promise is once broken. That means P happened but Q did not come, right? So this means P happened but Q did not happen. And this at same time with and, right? And the first one is, suppose this means P happens and then Q happens. Now if P does not happen, right, then Q might happen, right? This, suppose it is raining. Raining means P and I will carry umbrella. Umbrella means Q, right? Now it is not raining, then this statement is never violated, right? So I can, this fails only when P is true and Q is false, right? So this will be false, this will be false, right? If P then Q, either P did not happen or Q happened, right? And this is the identity, right? This is biconditional identity. It biconditional of P and Q means if and only P, if and only if Q, and P and Q should have same truth value for true. Suppose this is true, it will give true. This is false, this is false, it will give false. Sorry, true, right? For same truth value, it will be true, right? Now we will be solving some questions, right? So beginning with first one, we will practice some questions now. Right. Right. So now we will begin with first question. P and Q implies P or Q, and I have to prove these two statements. Next one is negation of P or Q or negation of P and Q or P. These both are tautologies. Right. These both statements are true. every row will be true, right? I have to prove this. So how can I prove this? I will use here identity, right? I will simply write negation of P or negation of Q, right? And or P or Q, right? Now, right. Now I will use. Now I will use identity. I will use distributivity. I will use associativity and commutativity, right? So I will write negation of P or P or negation of Q or Q. Here it is or, so it will be true. Here it is or, so it will give true, and this will give true, right? Now, next one is, here I will use negation, so this will be negation of P and negation of Q, or this will be negation of P and Q or P. Now I will use now distributivity, right? So here it is. Okay, what is here? This is the same thing, right? So I can also write, suppose this is A multiply B plus A multiply C, right? So I can also write it as A multiply B plus C, right? So simply I can write here negation of P or negation of Q negation of P and negation of Q or Q, right? So this will give me true, right? And this will also give me true, right? So overall it will be true, right? Now, third question is prove P or P and Q is equivalent to P, right? So I can write this as P or P and P or Q. P or P will give me P, right? Or simply I can write this as I have to prove this, right? I can write this as P and tautology. This will give me P or P and Q, right? So I can write this as P, right, and P or Q, right? T or Q will give me T, P and T will give me P, right? Fourth one is proof negation of P or Q or negation of P and Q will give me P is logically equivalent to P, right? So I will write here negation of P and negation of Q or negation of P and Q, right? This I can write it as negation of P, right? Negation of P, negation of P and this is A into P plus A into C. So I can write this as A B plus C. Right. Yes, I can write this as negation of P and Q or Q. Right. This I can write. Yes or no? Now, this will give me true negation of P and true will give me always negation of P and outside there is negation, so this will give me P simply, right? Next question is P and Q or P and negation of Q, right? So this will give me P or P and Q or negation of Q. This will give me, right, or this will give me true, right? Anyone should be true. P and true will give me P, right? I have to prove this as logically equivalent to P. Now, there are some questions related to biconditional theorem, right? So, next question is, so that P biconditional with Q, P if and only if Q is equivalent to P or Q implies P and Q, right? I have to prove this. So what I will do, I will write my identity first. This will be equivalent to P implies Q and Q implies P, right? And then I will write negation of P or Q and negation of Q or P, right? And this will be written as negation of P and negation of Q or negation or Q and negation of Q or negation of P and P or negation of P, right? And negation of Q, right? P with negation of and Q is okay. Q and P. This will be P, right? Q and P, right? This will be false. This will be false because negation and non-negation, both will have one false statement, so it will also always give false, right? And negation of P and negation of Q, or Q and P, this complete and this complete will give me the same thing, negation of P and negation of Q, or Q and P, right? Now this will be negation of P or Q or P and Q, right? Yes. So this can be written as P or Q implies P and Q. Hence proved. Right. Now, next question is, I am erasing this one. Next question is, prove P biconditional with Q is logically equivalent to P and Q, or negation of P and negation of Q, right? I will first write my identity as P implies to Q and Q implies to P, right? And then I will write this as negation of P or Q and negation of Q or P, right? Now I will write this as negation of P and negation of Q or Q negation of Q and negation of Q, right? Or negation of P and P or Q and P, right? This will be contradiction. This will be contradiction. This is what I have. So this will give me the same thing, negation of P and negation of Q, or this will give me, this both will give me P and Q, right? Because there is OR method. So when there is OR, we need only one. It does not mean that every time you will get a false, right? If there was an AND, so you might get contradiction, right? Suppose this is P and F and P or F. So P, T, F, and for F always F, right? And here it is P and F. So I will always get F, right? But for this I will get T, F, this will be P, right? This always gives P, right? Now last question is negation of P biconditional to Q will be logically equivalent to P biconditional with negation of Q, right? So I can write this as P implies Q and Q implies P, and outside there is negation, right? Then I can write this as negation of P implies Q, or negation of Q implies P, right? And I can write this as P. I will use identity here. Negation of A implies B will be logically equivalent to A and negation of B, right? A and negation of B. So this will be P and negation of Q, or Q and negation of P, right? And this will, I can write this as P implies negation of Q and negation of Q implies P, right? And then I can write this as P or negation of Q, negation of P or negation of Q, and Q or P, right? And then I can write this as negation of P and Q, or negation of P and P, or negation of Q and Q, or negation of Q and P, right? This will give me false, this will give me contradiction, right? And this will whole give me, because there is or, this will give me the same thing, or this will again give me the same thing. So LHS is equal to RHS, that's why these two are logically equivalent, hence proved. Now further we will discuss in next question, right?